Okay, so we're going to use this formula that we used on day 1 that found our total stopping distance, and we're going to rearrange it to make a new formula that we can plug into our calculator or into Desmos. So all I'm going to do is take this total distance and move it to the back by subtracting it. And once I show you this formula, you don't have to do it anymore. The formula will be on the quiz for you to use, okay? So if I move it to the back, I get VT, so velocity times time. I don't like this little P minus R, but it's there. It just means time. Plus V squared over 2, that's a mu, that's a Greek G, or a Greek M, sorry, G, and then I'm minusing the distance, the total distance, okay? So I have this new formula, but I want to put it in the ax squared plus bx plus c form. I want it to look like a quadratic equation. So I'm actually going to put this piece first, the yellow piece, then the orange piece, and then the blue piece. And we're going to get our new equation. So when I do that, I actually have it already written out for you. It's going to look like this. Okay, all I did was take the yellow piece, so this is now my yellow piece. I took out all those coefficients and left v squared by itself. And then I have the orange piece, I put the time in front, and then the total here. And we're going to use that formula to put in the calculator. So what kind of graph are we expecting? We're expecting a parabola, which looks like a U. Okay, and we are finding where the parabola crosses the x-axis, but we're only looking for the positive answers because this doesn't make sense if it was a negative one. So we're only looking for the right side of the formula, or of the graph. So here we've got all these numbers, right? Let me recopy my formula here. Okay, and we are going to highlight some stuff so you can see it. Total distance, 63 feet, that's going to go right here. And then the time is 0.7, that's going to go right here. And the mu, that's how the conditions of the road are, or the conditions of you are actually. If you're tired, if your car has anti-lock brakes, that kind of thing. But that's 0.6, and that's going to go here. Now the G is in there, and they're always implying that G is 32, and you should always just kind of remember that. So G will always kind of be listed as an unknown, but you should always put it as 32. So if I put all those numbers in, I get 1 divided by 2 times 0.6 times 32, plus my orange is 0.7, my time. Sorry, this should be V squared. 0.7V minus my total distance, 63. This right here is going to go into the calculator. So I'm going to bring up Desmos. Let me clear it out here. Okay, so we're going to put 1 divided by, if you hit just the division key, it gives you that nice fraction. 2 parentheses 0.6 parentheses 32. And now I've got a tap on the outside so the cursor is kind of level. And I'm putting x squared. We don't have a v, so I'm using x squared. Plus 0.7x minus 63. And you're going to have to pinch and pull the graph until we see it on here. There it is. I only care about this right intercept. And it says 37.5. We're going to round it. I don't care about this one on the negative side. I only want the 37.5. So when we get that answer, that's actually feet per second. Okay, the car can go a maximum of 37 feet per second, but we like miles per hour. So if I put that into our conversion formula over here, it's kind of opposite of what you were doing. You're going to multiply by 3,600, and you're going to divide by 5280. Before, on the last worksheet, you were multiplying by 5280 and dividing by 3,600. Okay, and we will get miles per hour once I put that in the calculator. So 37.5 times 3,600 divided by 5280. And I get 25.6 miles per hour. So I can go 25.6 miles per hour and stop by 63 feet, okay? If I have something that's in the road at 64 feet, I stop in time. The maximum speed I can go is 25.6 miles per hour. Okay, we'll do another one like that. I'm going to put my formula in there. It's always good to have a picture of it and then just kind of add it in. All right, and now we're going to put our pieces. I'll highlight again. So I've got the total distance is going here. I've got the time. 1 second is going right here. And I've got the mu is 0.9 going right there. The g is always 32. So we're going to put that in. 2.9, 32. It's v squared. The time is 1 second, so 1v. And the distance is 100 feet. So how far or how fast can I go if I want to stop in 100 feet? Okay. So we're going to bring back our equation. I'm just going to try to use this so I don't have to type it all out. I'm changing that to a 0.9. I'm changing this to a 1x. And it's minus 100. Okay. I don't need to take a picture of this or anything. I'm just looking at that right intercept, and it's 52.4, but remember that's in feet per second. So 52.4 feet per second, and we are going to convert it to miles per hour, and the chart is right there. So we're going to multiply by 3,600, divide by 5280. Okay, so I'm just going to go and change this to 52.4. And we get 35.7 miles per hour. If we want to stop in 100 feet, I can only go 35.7 miles per hour. Okay, and the ones below it, their 3 problems are exactly like this. I hope it helped, and I'm also going to have a full review video on the homework that I'm posting for Thursday. Take care.